For the following problem, I need to determine all the real and imaginary zeros of the given polynomial. For these problems, there are several steps you need to follow. The first step being determining how many zeros this polynomial is going to have. I could figure that out by looking at the degree of my polynomial. Since this polynomial is of degree 4, I know that in the end I should have 4 zeros. The next step is to actually find a zero. And the only way we know how to find a zero is to plug this polynomial into your calculator, go to the table, and look to see where y equals 0. When you do that, you will find that you have a zero at x equals 3. Once you determine one of your zeros, it may have more than one, you just need to pick one of them. You will then do synthetic division. Since x equals 3 is a zero of this polynomial, when you're doing synthetic division, your remainder should always be 0. This is a quartic, so on top I'm going to have x to the fourth, x cubed, x squared, x, and my constant. My coefficients are 2. I have 6, I have negative 15, I have negative 43, and I have a constant of negative 60. So for synthetic, step 1 is to carry down the 2. 3 times 2 is 6. 6 plus 6 is 12. 3 times 12 is 36. Negative 15 plus 36 is 21. 3 times 21 is 63. Negative 43 plus 63 is 20. And 3 times 20 is 60. So I did get 0 as my remainder, so I know that I did it correctly. The next step is to rewrite your new polynomial. As we've talked about, when you're dividing a polynomial by a linear function, your resulting quotient will always be 1 degree less. So since this started out as a quartic function, my quotient is going to be a cubic function. So I'm going to have 2x cubed plus 12x squared plus 21x plus 20 equal to 0. Once I get to this point, I have 4 terms. So I have 2 options. I could either A, check to see if this factors by grouping, or I could B, repeat step 3, go in my calculator, find another 0, and do synthetic division. This polynomial is not going to factor by grouping, so I could only do option 2. So I will look back in my calculator and find another 0. My other 0 that I found is at x equals negative 4. So I will set up another synthetic division problem with negative 4. I'm going to have an x cubed term, an x squared term, an x term, and a constant. We'll put 2 here, 12 here, 21, and 20. We'll bring down the 2. Negative 4 times 2 is negative 8. 12 plus negative 8 is 4. Negative 4 times 4 is negative 16. 21 plus negative 16 is 5. And negative 4 times 5 is negative 20. So once again, I got a remainder of 0. So I know I did it correctly. I will now write my resulting polynomial. Since I took my cubic function and divided it by a linear, my resulting function will be 1 degree less, which is a quadratic. It will be 2x squared plus 4x plus 5 equal to 0. Now that I have a quadratic, I will use the quadratic formula to find my remaining 2 roots. Recall the quadratic formula is x equals opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. So with my quadratic, my a value is 2, my b value is 4, and my c value is 5. I will simply substitute in those values into my formula. So I'm going to have x equals -4 plus or minus the square root of 4 squared minus 4 times a times c, and the whole entire thing is divided by 2 times a. I'm going to do a bit of simplifying, so what I will plug into my calculator is my discriminant. So everything I just circled underneath the square root, I will just plug that into my calculator. And when I do so, I will get square root of -24. I just separated these, so I have this -4/4, and then I have my radical over 4. -4 divided by 4 is just -1. So this is going to be -1 plus or minus. And we still need to simplify square root of -24. So the first thing when I'm simplifying square root of -24 is, since there's that negative sign there, I must pull out an I. So I will have square root 24I. Then you have to think of what two numbers can multiply to give you 24. Two numbers that I can think of are 4 and 6. 2 times 2 will give me 4. And 2 times 3 will give me 6. I found one pair, so that means my pair that I found will go out on the outside, and since 2 and 3 did not find a pair, they must stay underneath, and I could just multiply those back together to 6. And I cannot forget about that I that I pulled out. So square root of -24 is equal to 2 root 6i. So I'll just come over here and write that to replace square root of -24. And remember, that's all over 4. So you always want to simplify your answer as much as possible. And I could see that 2 divided by 4 simplifies to 1 over 2. So my final answer for solving the quadratic formula is -1 plus or minus root 6i over 2. The 1 is not necessary to put out front right here, but you can put it if you want. Remember, the question was asking us to determine all real and imaginary roots. So we actually have 4 of those. This is the first one. This is the second one. And this right here is 2 answers. So the final answer that we will put is 3, -4, -1 plus or minus square root of 6i over 2. And that is your final answer.